Because if you don't know it's a right triangle, you technically don't have legs yet. So that's why I say that they're the legs, or they're the shorter of the two sides. And C will be the length of the hypotenuse, or the longest side. And if you can prove that a squared plus b squared does in fact equal c squared, then you have a right triangle. And I think you actually saw some of these on your homework last night where it said, is it a right triangle? Oh no, you have, is it a Pythagorean triple? So is it a right triangle? You just have to test, does a squared plus b squared, does that equal c squared, basically. Again, a and b don't matter, but c has to be the largest and longest side. So a and b can be either of those numbers. I'm not putting an equal sign in right now because I don't know if they're equal. You're testing if they're equal. And then we can evaluate using our calculator. Don't expect you to do this math by hand. So 13 squared plus 84 squared gets me 7,225. And 85 squared gets me 7,225. So since these are equal, then yes, this is a right triangle. So now that we've learned this, you could actually go back to the bell ringer. We could actually prove that the big triangle was not a right triangle because it wouldn't satisfy the Pythagorean theorem once we found the side lengths. So once we found the square root of 65 squared, which would be 65, plus 5 squared will not equal 10 squared. So if you wanted to go back and test that, we could. And then we have two additional theorems today. These are going to be helping us to classify if the triangle is acute or obtuse. So again, C, in a triangle, C will be the length of the longest side. A and B are the lengths of the other two sides. And we have if c squared is greater than a squared plus b squared, then the triangle is obtuse. Now, normally we do a squared plus b squared equals c squared. Notice I've switched it around so that c squared comes first. The only reason that we do this is because it kind of makes sense to see a greater than in obtuse, because an obtuse is greater than 90, so like it kind of helps you to memorize it. If you would like to or prefer to keep it a squared plus b squared, it will actually be less than c squared will be obtuse. And kind of that just doesn't make sense to students. Less than and obtuse just don't run to themselves. So that's why I suggest that you flip it around and then it kind of makes sense. Theorem 8.4 says, again, if you have a triangle and C is still the longest side, A and B are the two shorter sides, if C squared is less than a squared plus b squared, then the triangle will be acute. So you're able to classify a triangle based on its angles without knowing any of the angles, just knowing the side lengths. If it's an obtuse triangle or if it's an acute triangle. And if you prefer, you may just want to always do the c squared. You'll see me do this. I put a little box there. And then at the end of the problem, I'll fill in the box with a greater than symbol, a less than symbol, or an equal to. And then I can classify it at the end. So describe each triangle as acute, obtuse, or right. So to do this, we are testing. We're going to compare the value of c squared with a squared plus b squared. Just make sure you realize that sometimes they don't put the numbers in chronological order. So sometimes they'll trick you and put the bigger number first or second and not third. But looking at this, you can see that this is definitely the biggest number, so that's our C. So we would have 17 squared compared with 11 squared and 14 squared. 17 squared is 289. We can evaluate those in our calculator. (11 squared plus 14 squared gets me 317. So they're not equal, so it's not a right triangle. Would we classify this as acute or obtuse? Marquise? Acute. We would fill this in with a less than symbol. This is a smaller. And less than means acute. You have to remember, if you're going to use the acute less than, that you set the c squared first and the a squared plus b squared. Some students will switch that. Okay, the next one we see, also the longest or largest side is our last number. So we would have, again, our c squared compared with a squared plus b squared. We get 64 compared with 34, which 64 is greater than. So this would be an obtuse triangle. In some of the cases, if you notice it's a triple, you can just go ahead and say it's a right triangle without doing any work, because we know that the triples would always prove that it's a right triangle. Now for our last one, what is the biggest number?
4.
4. 4 will be our c. If you're not sure, test out what the square root of 7 is in your calculator, and you'll see that it's 2.65 if you're rounding it. So it would be actually smaller than the 3. So you want to make sure that you identify c first, otherwise then the rest of the problem is kind of off. So this would be 4 squared compared with 3 squared plus the square root of 7 squared. Now, what do I get when I square the square root of 7? Right? 7. They undo one another. If you're going to type this in your calculator, which again, you all have different calculators, but if you want to type in the square root of 7, you're going to have to close your parentheses first. And actually, let's see if it works. You may need another set of parentheses. No, it worked. Sometimes you need another set of parentheses outside of it. But if you don't put those parentheses, you're going to get the wrong number. We will get 16 then is equal to 16, which means this is a right triangle. See if you guys can try examples 5 and 6 on the back on your own. And then we'll take a look at an application question. And we're going to do the closure together because it's a little bit harder. So again, if you notice this is a triple, this is a 3, 4, 5, which is a triple, works for right triangles only. You notice that it's times 2, which gets you a 6, 8, 10. If it's a triple, it has to be a right triangle. You also could prove it 100 equals 100. And then what do we get for number 6? Acute, obtuse, or right? Stephen, what'd you get? Very good. Again, just make sure you don't fall into the trap. The biggest value here was 16. So we should have compared 16 squared with 15 squared plus 9 squared, which gets us 256 is less than 306. So that was an acute triangle. All right, the next one is actually kind of like the walkway question from yesterday. So before flat screens and LCDs, a typical television screen was in the shape of a square. Suppose you purchase a TV from Best Buy. So we have a square, first of all. Not my best square I ever drew, but it's okay. I'll mark it. The diagonal is 24 inches. Which I believe this is the exact same numbers from the homework last time. Except it was a walkway with a pathway with the garden. Find the dimensions of the TV screen. Ooh, and find the area of the screen. So if it's a square, we know the dimensions are all the same. That's why we have these markings, which means if we don't know what the side length is, we can divide a variable. X, A, B, S, whatever. And we know in a square we do have 4 right angles. So we can complete the Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus x squared equals 24 squared. So this is the one that you're going to have to combine like terms. We have 1x squared plus 1x squared, which gets us 2x squared, equals 576. Can I square root right now? No, we have to get x squared by itself first. So we will divide both sides by 2 to get us 288. And then we will square root. Now since it does ask us for the dimensions, we will want to simplify our answer here. We'll just do simplest radical form because I know you all know how to type it in your calculator. We can practice that. What would I break 288 down into? We get perfect square. You need to grab your calculator. Lexi? Yes. So she broke that into the square root of 144 and the square root of 2. And then the square root of 144 is 12. And that would be 12 root 2 inches. Technically, if it wants dimensions, that's also by 12 root 2 inches. Would be the dimensions, because it's length times width, but in a square they're both the same. They also asked us to find the area. You can either use the area of a square formula. Who remembers the area of a square formula? Area equals, Marquise? That'd be the area of a rectangle. It works for a square too, but there's a formula actually for squares, Ethan.
X squared.
Yes. S squared, x squared, whatever. Okay? And in this case it would be x times x, which would be x squared. So if you use length times width, you're going to get the same thing. So I'll plug in what I found for x, which was 12 root 2 squared. And if you're going to square this, you have to remember to square each of the terms. You have to square the 12 and the square root of 2. So this would be 12 squared times the square root of 2 squared, which will get me 144, times 2 and the square root of 2. Those undo one another to just get me 2. And look at that, I get right back to what I had before I square rooted it. 288. Units would be square inches. Now, just as a little side note, what if I asked you to find the perimeter? They didn't ask us, but it's always good to. Brett?
P equals 4s. Or 4.
Okay, so you're going to be the perimeter. Perimeter formula for a square would be 4s. 4x. And then we'd have to evaluate what x is. Now, do I get 48 square root 2, or do I get 48 square root 8? Joseph? Good. You can only multiply outside numbers. So 48 root 2, and that would just be plain inches. If you were to actually add them all, 12 root 2 plus 12 root 2 plus 12 root 2 plus 12 root 2, make sure that whenever you add square roots, you realize that you don't actually add the root. It's like terms, like 1x plus 1x is 2x. So you would just add the outside numbers and get 48, and then you would keep that like root together. Square root, in case you added them instead of using the formula. All right, our closure question is going to require us to possibly use our prior knowledge about the geometric mean. The reason we're allowed to use the geometric mean is we see a right angle, technically this would also be a right angle. So we have 3 right triangles inside, 2 inside of another. Now, first of all, one of the values should be able to be easily found using Pythagorean theorem and or triples. Either x, y, t, or z. Which variable should we be able to find really quickly using triples. Marquise?
Z.
Z, what would Z be? Katie? 50. This is a 3, 4, 5 times 10. So it's a 30, 40, 50. So Z is 50. And then from there, the problem is we don't know like how this is divvied up. Like is it 10 and 40, 30 and 20? We don't know. So we would have to, because we only know one side in this right triangle and we only know one side in this right triangle, we would have to use our geometric mean. And we can't use the middle one because that would get me more variables. So we have to pick one of the legs. Doesn't matter which one you pick. Let's start with 40. So 40 is a geometric mean, which means it would go in our slots 2 and 3 or 1 and 4. What numbers and variables would I put in the other 2 spots? What number and or variable would I put in the other 2 spots? Mira?
50 and 50 minus y or x.
You could do 50 minus x, but you actually can just use y. Because y is the piece that we need. It's the part that's closest to it, and then the whole thing is 50. But if you did 50 minus x, you would find x then instead of y, and then you could find it. So we'll cross multiply, and we'll get 50y equals 1600. Divide by 50, and we will get y is 32. And then you really only have, that's the only time you have to do the geometric mean. From there, you can actually do Pythagorean theorem to find all the other ones. If you want to use geometric mean, though, you could. We can also just do subtraction here, right? 50 minus 32 will get me 18. Then you don't have to do anymore. So x is 18. And then lastly, you could either do geometric mean with t, or you can do Pythagorean theorem with this triangle or this triangle. Doesn't matter which one you do. I chose to do Pythagorean theorem, which it's probably, could be a triple. We also could have done your geometric mean, t, 18, and 32, if you prefer. But we should get that t is 24. And these would all be meters. I should have had units. Alright, so sometimes you may have to use some prior knowledge, but remember you can only use the geometric mean if you see 3 right triangles, a big one and 2 small ones.